Introducing Paddy's creation.
Yeah, so this is the Paddy Mark III fridge. This is the condensing unit. It operates pretty much the same as most large domestic or small industrial freezers would, with a couple of additions to the system to allow it to work properly on a boat. So suction line comes in through here, through this valve, into a device here which is called a suction line accumulator. This prevents a problem that you can get, particularly on boats in rough conditions with liquid refrigerant coming back through the compressor, and it causes a problem called liquid slugging, which is really bad for the compressor. The accumulator separates all that out and tidies that up for us. The output then comes through from the accumulator into the compressor unit. This is a Hermetic compressor, Italian made Embraer compressor. And then we have the output from the compressor that goes through the first of the two condensers. We have a water-cooled condenser that operates down here, and then we have a more standard air-cooled condenser at the front here that runs with a big fan on it. So we've got lots and lots of condensing capacity, which allows us to operate very efficiently in warmer climates. Once we come through the condenser, we come back to the liquid accumulator here, and then off back out to the evaporators and the thermal expansion valves. Now, there's a couple of safety features that we've included into the fridge. So we've got a high pressure cutout and a low pressure cutout, so if anything actually goes wrong with the fridge, the whole system will basically shut down until such time as that's been sorted out. The other thing that we've had to do for running the fridge on a boat, which means we're either running off the genset or potentially through the inverter if we don't have the genset available, is with a reciprocating compressor like this, they start under load. Now that tends to mean that the startup current draw for the compressor is actually really high, and that can exceed the capacity of the inverter or even potentially cause a generator to stall out. So to prevent that from happening, we've got a what they call an unloader circuit here. So we have a one-way check valve, which is down here, and a bypass here, which is a solenoid which runs in the normally open configuration. So what happens is the control unit starts up the condenser, and then for a brief period of time the condenser is actually bypassed out of the refrigeration circuit, so essentially starts off load. Then a few seconds after the compressor is started, that solenoid is energized and closes, and the refrigeration circuit carries on. So that vastly reduces our startup current draw on the compressor. It's a reasonably large compressor. It's 1.25 horsepower in total, which is probably bigger than you'd have in any kind of domestic freezer. But the design parameters for this are around allowing us to pull down the eutectic plates. There's 3 eutectic plates, each with their own thermal expansion valve. In the freezer cabinet, we want to be able to pull those down inside of about an hour's worth of running. So we've had to go fairly large on the compressor and associated componentry. And as I said, we've put lots and lots of condensing capacity on it to allow us to do that using the least possible amount of energy. So we've just connected everything up together, and we leak tested it, pressure tested it to 300 psi because we're using 404A, which is quite a high pressure refrigerant. We didn't have too many leaks, a few things to sort out. I guess one thing that I learned in the whole process of it, there are quite a few people on YouTube that will talk about using soft solder to do all of your refrigeration joints. My experience of that is, if you're like me and not brilliant at your soldering and pipe joining technique, you do spend quite a bit of time chasing leaks around to get all of your joints sorted out properly. So if I was doing it again, I probably would have avoided the soft solder and just gone with a high silver content brazing rod. Obviously you need to nitrogen purge if you're brazing to prevent the production of copper oxide on the inside of your pipes, which of course is the claim to fame of the soft solder. Because you're operating at a lower temperature, you don't need to do that. However, given the day or so that I spent having to chase around and find all of my little pinhole leaks and bits and pieces, I would say if I was doing it again, I'd braze all of the joints. I'm sure the soft solder works fine, just need to be better at using it than I am. So if, like me, you're not fantastic at it and highly skilled, just do what everyone else does and braze your joints. Done.